Juno flight system is launched from Earth in August 2011. About a year later, a pair of deep space maneuvers uses the flight system's main engine for the first time to slow Juno and set up an Earth flyby gravity assist in October 2013. The Earth flyby provides the opportunity to exercise the science payload and flow observational data from the instruments to the science community. The Earth flyby also exposes the flight system to the only post-launch solar eclipse of Juno's mission. About 5 years after launch and a little less than 3 years after the Earth flyby, the flight system reaches Jupiter with an approach over the North Pole. Juno's investigations of Jupiter focus on 4 themes: origin, interior structure, atmospheric composition and dynamics, and the polar magnetosphere. No other object in the solar system can tell us more about the origin of the planets than Jupiter. The record of Jupiter's origin and early evolution lies hidden deep within the planet's interior. In addition, Jupiter has the most massive atmosphere of all the planets, and Jupiter's magnetosphere is the largest structure in the solar system. The Jupiter orbit insertion burn is a mission-critical event. Arrival is timed to provide dual DSN station coverage with the Goldstone and Canberra tracking complexes, and to correspond to a minimum in Jupiter's magnetic field, thus reducing the electromagnetic effects of a spinning spacecraft on key engineering subsystems. During the execution of the insertion burn, the flight system turns to a fixed burn direction and increases its spin rate before firing the main engine. The entire orbit insertion critical sequence is performed in view of the Earth. Subcarrier tones from the toroidal antenna provide flight operations team with necessary engineering information. The insertion burn places Juno into a 78-day capture orbit with apogee at a distance of 145 Jupiter radii. A 4th and final main engine burn is required to reduce to an 11-day orbit period for science operations. The apogee of this orbit is at a distance of approximately 39 Jupiter radii, with perigee at a distance of approximately 4,500 kilometers. The first of 2 science orbit types, called an MWR orbit, is exercised on orbits 3 and 5 through 8, and is characterized by a flight system attitude in which the spin plane passes through the center of Jupiter. This attitude allows Juno's microwave radiometer and other remote sensing instruments to observe Jupiter's aurora and atmosphere during the perigee passage. The second science orbit type, called a gravity science orbit, is exercised on orbits 4 and 9 through 32, and is characterized by a flight system attitude in which two-way Doppler X-band and Ka-band links are maintained with a DSN tracking station on Earth for the duration of the perigee pass. The Doppler measurements are essential for determining the distribution of Jupiter's mass. Juno's fields and particles instruments participate in both science orbit types, obtaining measurements of Jupiter's magnetic fields, plasma waves, and radio emissions. As Juno travels through the Jupiter system, it becomes an integral part of the resident magnetic environment, enabling it to observe phenomena along field lines that carry extraordinary amounts of energy crashing into Jupiter's polar regions. The orbital trajectory is designed such that during the perigee passages of orbits 3 through 17, a global map is obtained at 24 degrees spacing in longitude. With an 11-day orbit, the Jupiter longitude of each successful perigee is designed to differ from the previous one by 192 degrees. After 15 science orbits, the map is complete at 24 degree spacing. An offset of 12 degrees in longitude is implemented before starting another 15 orbits, continuing with orbit-to-orbit increments of 192 degrees. With the perigee passages of orbits 18 through 32, the 24 degrees spacing is split in half, resulting in a final global map with 12 degrees longitudinal spacing. Orbit 33 provides a perigee pass that has been held in reserve. It is designed to replace any longitude that may have been missed due to anomalous behavior on any single perigee of the previous 30 orbits. A deorbit maneuver is performed near apogee of the 33rd orbit, placing the flight system on a path for impact with Jupiter and compliance with planetary protection requirements.